On this slide, we talk about three sets. So we have written the formula about two sets, A and B. Now we will write a formula about three sets, A, B and C, and link union of A, B, C with number of elements in A, number of elements in B, and their intersections. So this is set A, this is set B, say, and this is set C. So all these lie in this big rectangle of universal set U. So let me quickly write down the formula first. So we will not give an explanation for it, but you can see its validity by looking at the diagram. So number of elements in A union B union C is given as number of elements in A plus number of elements in B plus number of elements in C minus number of elements which lie both in A and B minus again number of elements which lie both in B and C, then minus again number of elements which lie in both A and C, and then plus number of elements which lie in A, B and C. So the last is plus. So in the end you add number of elements which lie in all three sets. So for example, if you are given number of elements in A is 50, number of elements in B is 55, number of elements in C is 25, so in A intersection B there are say 5 elements. In B intersection C there are 15 elements, and in A intersection C there are 10 elements, and the number of elements in A intersection B intersection C are 2. So we start plugging in the numbers here. So you have 50, 55, 25, minus 5, minus 15, minus 10, plus 2. Add them up, you get 102. So this is how we can compute the total number of elements in A union B union C. But most likely we will be given a story associated with the above formula. So let us write down the story. Yeah, so in problems there would be a story rather than this direct values. So number of A could be number of people playing football. So set A could be people playing football. So NA is number of people who play football. So number of people who play football is say 50. So I will just associate a number. So B is people who play tennis. So 55 people play tennis. 25 people play hockey. So number of people who play hockey is 25. So then we have number of people who play football and tennis, 5. So 5 is number of people who play football and tennis. Then 15 is the number of people who play tennis and hockey. Ten is the number of people who play football and hockey. And 2 is the number of people who play all 3 sports: football and tennis and hockey. And the question would be to compute number of people who play football or hockey or tennis. So notice for intersections we have and, football and tennis and hockey. In fact, for each of the intersections we have word and. So you have to be able to link this word and with intersections and word or with unions. So this word or means, so we are asked to compute N A union B union C. Sometimes people reword this question and is the same as above question, that compute number of people which play at least one game. So that also means they play football or hockey or tennis. And the answer is this number of elements in A union B union C, which is 120.